Let's see if we can get the...
You're good. Go. You should be able to share your screen. Is that?
Okay, yep, there we go.
Awesome.
And can everybody see this? Is this good?
Yep, perfect.
Okay, let's break this out here. Yeah, thank you for the intro, and thanks for having me, Dan and Rylan. Excited to kind of share what we've kind of been discovering as we've been building out Sublayer. A little bit more into the technical details of what we're doing. We're kind of building AI agents to write software for us. So think, autonomous developers, but more of the interface for interacting with them. And so I guess I can kind of skip my about me slide. Been using Ruby for a very long time, and chose it for my last startup, chose it for Sublayer. And so I have said for a long time that I see Ruby as my competitive advantage. The things you can do with it with so little work and get so much done so quickly sets you apart from basically anybody using anything else. Which not just mine. This is older data, but it's from I think 2019 Y Combinator's breakdown of primary backend language. Ruby's total valuation kind of knocks everybody else out of the park. So it's not just I'm not just the only weirdo. There's a lot more of us out there than we think. There's also another way that people kind of can view which I felt like I had to throw this into the talk because where I'm going to go next takes on a little different perspective given the chaos that DHH has created for all of us. But to kind of kick this off, the way that a handful of people have given talks and written posts about there are kind of two schools of thought, two types of developers, kind of breaking down like the ways that people kind of approach programming. Steve Yegi has a post, notes from the Mystery Machine Bus, where he breaks it down with political labels, not absolutely tied to the political spectrum, but using those as terms of conservative and liberal. Avdi Grimm has another great talk, The Soul of Software, where he breaks it down using terms from a book called Object Thinking, that there's the formalist school and the informalist school. And given some of the debates that have been going on the last week, that you kind of can see that the pendulum is swinging more toward, has been for a long time swinging more toward the formalist school. But like a little bit of historical perspective, one way that you can kind of look at this holy war that's been going on for decades is that the primary school of thought has kind of shifted. And I'm skipping over a lot here, but kind of think of when Smalltalk and the ideas that were coming out of Xerox PARC around object-oriented programming and the GUI. There was a lot more of informality as people were exploring new technologies, coming up with ideas, and kind of just like trying things out. Once they found things that worked, you started to see the C++ and Java formalize it and put some structure on it, make it stable, make it reliable. And then, I think when I was getting into Ruby and Rails, it was a big backlash of all of the button-up structure of Java and, breaking those shackles and like actually getting stuff done with Ruby and not having to worry about all of the Java nonsense, for lack of a better word. And through the 2010s, like the slide earlier from Y Combinator, Rails was kind of the language, or Rails was the framework, and Ruby was the language of IPOs through the 2010s. And there's a reason for that. There was a whole bunch of people trying out a whole bunch of different things, and a lot of those ideas worked. And then TypeScript, Rust, a lot of more of the structure formalism kind of came along and codified those patterns that people discovered, and put structure on it, made it more stable. These were these were a lot less of people throwing stuff at the wall and seeing what worked in the early stages, and then finding things that worked and needed to scale them up. This is, we figured out MVC and REST, and we're comfortable with it, and now let's put structure around it. Let's do it. But that, the pendulum is going to swing back, and we kind of see LLMs as being one of the drivers of that, as we kind of figure out what does it mean to program with generative AI. And one of the ideas, just kind of throwing this out there, nobody's really kind of nailed this yet, but the idea of LLM core, where they, maybe we're going to dial down a little bit of the, reliance on the programming that we do being deterministic. And what do we get by dialing that down? I don't know yet, but it's a fun thought experiment. And if anybody has any ideas, I'd love to talk to you about it. I think it's a really fun kind of thought experiment to discuss. And then one more thing before I get into kind of the meat of all of this, one of the ways, and this kind of came from my last startup as we were working with voice assistants, one of the ways that a lot of people, approach and think about new technologies is usually from a starting point of what nature's done. And so when people were thinking about how are we going to fly, the starting point was, oh, maybe we'll fly like birds do. And, you spend some time with science and engineering, and it turns out that it's much easier to fly if you take a metal tube and you shoot fire out the back than try to and then the same with kind of dishwashers, right? There's the sci-fi idea of humanoid robots standing behind a sink and scrubbing your dishes for you, but it's a lot cheaper and a lot easier to spray the huge chunks off and put the dishes somewhere, put the the silverware in the silverware basket, and then put it in a metal cube and spray it with hot water. That's a much easier problem and kind of works. It does the job, right? And so with that framing, one of the things that we started thinking about was are we doing the same thing with the conversational interface? And it was a big kind of conversation. It was a big debate at my last company where we would say the conversational interface is a great interface when you're interacting with another person, but when you're interacting with a machine, there's a lot of steps that go into that, when it's a lot easier to just press a button to get something done, right? And given that, one of the questions we started asking ourselves, and also inspired by the idea of the dishwasher, what are the things that we can do to make it really easy for the machines to do the programming for us? And realize that there are going to be architecture patterns, languages, frameworks, styles, etc., that lend themselves well to writing a short prompt and getting working code out. And then there are going to be things that you do that make that really hard. And for your day-to-day work, for your team, for your company, it's going to be very important that you do the things that make it easy and avoid the things that make it hard or impossible, because the LLMs and the generative AI is really fast at doing a lot of these things. And if you do it right, you can kind of get the similar benefits that we get with Rails, where you name your file this. If you don't really care that much about what your primary key is and just do what the Rails way is, everything just kind of works and you can get a lot done. And so we started talking about that, and we started using the term promptable architecture, and started to see what lends itself well to that, and what doesn't. And some of the first things that we found are things like component-based design, where you have smaller reusable components that they're small enough that you can even put the entire thing into your prompt or into the context, so that when you're saying here's this component, I want it to do this, this, and this, you don't actually have to do much work to chop it up, or or the second piece here, the self-contained functionality. You don't have to say, and then change this, and then change this, and pull data from here, and make sure this library and all these things, where as long as it's self-contained, you can write a really simple prompt. And, again, clear interfaces and contracts where you can define what the inputs should be and what the outputs should be. That makes it really easy to write a good prompt. It makes it really easy to understand and read the code that comes out of it and be confident that it's correct. Take a beat. But I'm sure all of you are thinking we already know all of this. Like we already do. We argue about this and we try to do this in our day-to-day work. But the thing that I've found useful about all of those and coming at it from this angle is that we came up with them, we invented them, we came up with and we use them with the idea that it's easy for you and it's easy for me to understand and work with each other's code. And that leads us to think certain thoughts and have certain ideas of places to take that. But if you come at it from the standpoint of, I'm doing this because it makes it easy to write a prompt, it makes it easy to understand the code that comes out on the other end of this generative AI, you might take it in different directions. You might think new thoughts, you might have new ideas that you maybe couldn't have before with that perspective. And also, I've personally had this argument in teams before where, we need to do it this way because over the lifetime of the project, we'll see the benefits. We won't be slowed down by doing things one way or the other way. If we just get this right up front and we invest the time, that argument kind of changes too, right? Like it becomes, we're actually going to see these benefits today because I'm going to put that into ChatGPT or GPT-4 API or whatever LLM you're using, and it's going to write the code for me. And I'm going to keep being able to do that if I keep, following these patterns that lend themselves well to that. And so I found that super valuable and wanted to kind of share those kind of high level ideas. But where I want to go next is that there are a bunch of concepts and ideas from my time in Ruby and Rails that I see in this world where we're dealing with non-deterministic answers from these LLMs being really helpful in this kind of future. And so the first one that the Ruby world has really embraced is that there's more than one way to do a thing. All of these method aliases that you see, versus collect or select reject or array.42 from Rails, and if and unless, and the reason that we do these are for aesthetic reasons, or it makes the code easier for me to understand, you to understand, and that's the reasoning why we do it. The flip side is being comfortable seeing that this person on my team does it this way, and they did it that way for a reason, but it works, it's okay. If we're getting kind of different responses from these generative AI tools, being comfortable with like, okay, it used unless here, is that okay? It used if here, it used it used this pattern, it called something this, but it still works, like, and it gave it to me in seconds. Like, is it really that bad, or am I okay with this? And then taking that a step further, the idea of duck typing, where you don't really necessarily need to worry about what the type of the thing is that you're working with, as long as it has the behavior that you're trying to do. It's okay, right? That mentality we see kind of extending even further to if it passes the test, if it passes product acceptance, if the users understand how to use the feature and it's performant enough, and I got that written by the LLM in a few minutes, do we really need to spend how much do we care about this? And like being able to kind of ask ourselves that, and being comfortable and okay with it hits the parts that we need it to hit, maybe that's okay. But all of those things kind of lead into another thing from the Ruby community that I really picked up, was that the big reliance and culture of testing. I know in my early Ruby days, there was just like tens of libraries that you could choose from for different types of testing. People were coming up with new libraries and new patterns and new ideas all the time. And that's always been for me like a big conversation at any Ruby team that I'm on. And there are a bunch of different reasons why that's going to be even more important going forward. I don't know about many of you, but I've caught myself blindly accepting Copilot suggestions and then running it and being like, that doesn't make sense at all. For a long time, people made comments around, the idea of, oh, that person just, blindly copy and pasted from Stack Overflow. That's going to move to that person blindly copy and pasted from ChatGPT. And there's not really going to be a way to kind of put that, turn that off, right? Like a lot of people are already very comfortable with Copilot in their editor. From senior engineers to people just starting their careers now, going through school with Copilot. There was the story of like Sully Sullenberger landing in the Hudson, and him having the experience of flying in the military versus a lot of commercial pilots getting relying on autopilot. That if it weren't him, maybe they might not have been able to operate the plane by hand. We might be getting into that world where we're a lot of the teams and a lot of our team members, or even us, are get too used to the autopilot part of coding. But where we're going to be saved is the tests that we write, and that we can be sure of that the functionality is still there. And when things break, having something to rely on to kind of guide us back to being able to run. Let's see, there was something else I wanted to mention here. But yeah, blanking on it. But the one final thing here, and it's something that was big in Rails and hasn't really hit the spread to other communities, is the convention over configuration that I kind of mentioned earlier. That you follow the Rails way, things just work and you get a lot from it. That philosophy or that pattern lends itself really well to getting code generated from generative AI tools, because all the open source, all of the documentation, the blogging, the training ends up learning those conventions, and it does really well at if this is a model, this is a controller, it's going to be named this, it's going to be inflected this way, it's going to be in this folder, primary key is going to be that, foreign key is going to be this, and that's super powerful. One of the ideas that we've been tossing around is, do we get into this world of kind of convention oriented programming where you define the conventions and then the generators kind of generate to your conventions? But one of the other powerful things that the convention over configuration and the convention of Rails has enabled us to do, and tied in with Ruby, one good example is the meta programming that you see in Active Record. That, like I mentioned earlier, the class is named this, the file's here, etc. All of that lets Active Record, and if you follow those conventions, it lets Active Record look at the database tables and enhance those classes without you having to write any code. And the database, ends up being the source for the place that the meta programming works on to kind of fill out those classes. And that, I think, that leads me to one of the things that I think is super exciting about this world of LLMs writing code and Ruby, is that maybe I could be wrong. There might be more of them out there, but Ruby seems to me one of the few mainstream languages that is this open to kind of runtime modification. And right now we've got these static resources like databases, but apologize for the Python. But this one library recently kind of like turned a light bulb went off for me when I was reading this. And so this is an example from this library Marvin, where they've come up with a way to get the LLM to select from an enum given natural language. And so the example that they give on their README is a list of routes with names, and then sending the LLM update my name and it returning the route that you would put. And sounds like nonsense, right? That, like, even as I was saying, like, dial down the determinism, my mind didn't immediately go to, well, yeah, like our routes, like choosing our routes will be done by that. That kind of makes me a little nervous thinking about the applications that I write. But I also kind of took a step back and was thinking, a lot of people, when Rails was coming out, and a lot of the conversations about monkey patching and meta programming probably made them very uncomfortable to think that, you mean methods can just be added to my classes at runtime, and I'm not, like, it's not going to, the code's not going to exist anywhere for me to read and understand. And so maybe this is something that we either need to get comfortable with or decide we're never going to get comfortable with. But people might start doing things like this. And so I kind of was thinking about that over the last week or so, and kind of put this together today for all of you, where I started thinking about how you might metaprogram with these things. So here's a quick example that you'll check out real quick. And
Wow.
I actually have this working, so like after the talk, if anybody is interested, I can like show you a really simple demo of this. But also makes me very uncomfortable to think about doing and working, but seems really interesting and fun. But that is the end of the talk. I can jump over to any past slides. Anybody has any questions or comments, but thank you so much for share some of the stuff that we've been talking about.
I got some questions with that.
Yeah.
I mean, that last slide was like dropping that was dropping the mic for sure. So my first question is, when you talk about duck product, you were talking about like a product that like just does what you want it to do, right? Essentially, right? Which is really what we want, what every normal user wants of software. But and they don't care about implementation. The reason why developers are so precious and care about implementation is they're responsible for moving the software forward, right? So it's not enough that it works in the present time. We need to know how to make it work in the future with new requirements or new pieces of hardware or whatnot. So how does the duck product concept work with that?
Yeah, we're kind of thinking about it like, we're trying to build kind of an abstraction layer on top of the code that we're doing. And so the way we're kind of looking at it is, just kind of regenerate the whole app as you add new functionality. And the implementation might be different. The analogy we've kind of been using is compilers, where, you don't necessarily look at the assembly that your C compiler spits out all the time. But it just regenerates it, right? We're thinking like that could be a potential future.
Sure.
Let's see. So, great talk. And I have a question about the idea of like blindly accepting what OpenAI would produce. right? And then talking about like the culture of testing, right? And it sounded like you were suggesting that this culture of testing could sort of prevent just blindly accepting what OpenAI would produce. But like, if people are just accepting whatever OpenAI produces, what's to say they won't also just blindly accept what OpenAI produces for the tests as well?
A good question.
So now we have two problems instead of one.
I mean, we've gone down that path of, if you're trusting the AI to write your tests and the code, like you can't really trust it at all because it can just like have the test say like return true, right? It can make the test pass without actually doing it. So I don't have an answer to that yet, but I think there's still like, if you're one of the few out there that like Cucumber or RSpec or what you like, I think that you're safe there at least, where this is what makes a quality test. It's failed for the right reason, and it passes for the right reason. I think that still kind of is one of those things where you would need to trust yourself, or you would need to know that you or somebody on your team is actually doing something like that.
I wonder if this is a use case for adversarial AI.
Oh, yeah.
Two different AIs fighting to write tests and code.
Yeah, interesting.
I'm curious about what happens in the last example where you are at runtime, you're defining a method from the AI, but then what happens if that model changes, gets retrained, and it generates something different? Because like that's at runtime, so like you can't test that. Like with the Rails, like magic finders or whatever, those are sort of predictable of what that's going to spit out.
Yeah, I mean, and so I think that's a little bit kind of also tied in with this, and the answer is probably like maybe, and maybe we start to get comfortable with like the software not doing the right thing, and you have to go back and do it again until you get the right thing. But one of the other things that you can start to see. Rails doesn't look at the database every single time to see like what attributes are there. It caches them, right? Once we've been using like the pave the cow paths analogy, where maybe the first few times it generates it from OpenAI until it starts, you start to be comfortable with like, this is actually what we want. And then you cache it and you don't like, you don't have to look it up externally. You write it to a file and it starts to become part of your code base, but it kind of proves itself that it needs to be there, or that it deserves to be there, and it's right the way that you have it written. And yeah, the other, I haven't gone down, don't have that for the demo, but like kind of gone down a little bit of the like, could we use this as an aid for test-driven development where, you're writing the failing tests and it kind of just keeps doing this and writing this until it passes, and then it writes that to the file.
So I had a question about like kind of a more meta question is, my understanding is that all these LLMs need to get trained on a lot of data, and the more data you have, the better the output is. And so does that put Rubies that are, or languages that are more niche? And I consider Ruby to be kind of a niche language, right? Like maybe it's top 10, top 20. It's not niche like OCaml, right? But it's niche. It's definitely more niche than Java or .NET, C# whatnot. So do you feel like that helps or hurts Ruby kind of in the long term?
I haven't really had, Ruby has a really, well, I guess, a couple of unique things to it that a lot of other, even the popular languages don't have, where, all through the late aughts and the 2010s with like the rise of GitHub and everything, like Ruby has a very, a very open source culture, very sharing culture. And so while Ruby blogs don't exist the way that they did, a long time back in my day, that data is all out there on the internet, and these models have been trained on it, right? The Objective-C world doesn't have as like open, so as an open source culture as Ruby does, and even like the culture of like using MIT licensing for the libraries lends itself really well to getting these like code generating models that are really rely on being able to convince you or actually prove that they're giving you code and generating code for you that you can actually use, and you're not like violating any copyrights.
Right.
Ruby does really well, but you're absolutely right that like the more niche languages are really kind of hurt in this world today. I think that it will be kind of on library writers, language writers to find ways to write documentation and set things up for training for these models. Because why would I use a brand new library where I have to write it myself when there's another one out there that one of these models knows how to write, or can just like write it by hand itself, right? So the documentation thing will probably shift a little bit as well.
Can you demo that code?
Yeah, sure. Let's see. Let's switch over. And I'm always nervous about live demos, but we'll do it.
I'm wondering if that's all you need to write the entire app is method missing.
I've written all of your apps for you with this method.
Just write your test suite first.
Test for security.
So just a toy demo here. I've got the method generator module with a little bit extra from what I had before, but just including it into this calculator class that's completely empty, and so we've got this calc class, and say add 2 and 3. Add isn't implemented yet. Calling AI to open AI to request implementation. You want to add this implementation? Yeah, sure. Add 10 and 20. Simple calculator, right? We can do multiply 5 and 100, and multiply isn't implemented yet. Let's see here. Cool, that looks right. Oh no. Oh, so there we go. The non-deterministic response here kind of ruined things for us, where it came back with method generator def method. Let's try again. Oh, live demos failing here. But you can kind of see what kind of problems. There we go. Def method multiply. Anywho,
so if OpenAI charges by token, how much code can you write before it's as expensive as a regular developer?
That's a good question. I haven't done any cost experiments yet, but this isn't too many tokens, right? A few dollars, but.
That's cool.
Right.
Doesn't have to like to do this for multiply, but some of the other stuff it will.
Because you could easily have this, instead of just injecting the just providing the method body, you could also say write me some tests too.
Oh yeah.
Right.
Oh, 100%. Yeah.
And you still have to read it, right? Like, I feel like this is turning us into editors more than writers in some sense, because you still have to know what I'm doing, at least at this level, right? At least the tests.
We have a client that since they're so regulated, they don't want to even touch this stuff. Because we're like, okay, we're not sharing this stuff with anybody. We're not, we don't want to open ourselves up. So it's interesting. Yeah, I've been using I've been using Copilot on other projects, like, okay, now I'm without it again, okay. I still look like I still know how to do it.
Oh, yeah.
Well, I listened to NPR, they had like generative AI people on, they said that they found that Copilot helped people who didn't know what they were doing more. And that was in a customer service context.
Yeah.
But I think from a developer context, it's gonna help you more if you know the
Yes,
basics.
I agree.
Because then you know the words and the jargon and the things to ask it, right? Like, if
Right,
you don't know what a cache is, how are you gonna ask OpenAI to build you a cache or to
Right.
cache something?
make me cash is what it's gonna say, oh no. Yeah, printed? Yeah, printed. Yeah, you have to know how to read what it's producing, really.
Right.
You really have to.
I think it's an awesome tool if you're an experienced developer, but if you're not, if you're a junior, how are you learning new things? And one of the
Unless you
things-
take the time and study what it's
Right.
produced and use it as a guide to learning. It's the only way you can do it, I think. If
But there's pressure to get stuff done.
there's pressure to get stuff done anywhere.
So I can tell you from like a junior perspective, that especially when I was using like ChatGPT when it first like kind of like started becoming more popular, and especially Copilot, I was kind of like blindly accepting a lot of what it was giving me. And then of course I think somebody else mentioned like you can kind of burn yourself if you're like let it run its course and you don't pay attention. And the more I've learned, the more I can kind of like spot like, okay, I can already tell like right now that this is not what I'm looking for. And so maybe not learning in a way like in a traditional form, but also learning in like a different way and like picking up on things a little bit quicker because of the mistakes that were made. So I don't know, I guess like a little bit push and pull from it, but yeah.
It's very similar to what people probably used to say, don't look at Stack Overflow when you run into an issue. To me, right now, my process works to try and do it myself, search when I have an issue, Stack Overflow, Google, that kind of stuff. And my last resort is always ChatGPT, just because I'm not super familiar with it. But usually by the time I get to that, it's miraculous how quickly, and I've already done enough research that I know what I'm like, when it's going to be right. So yeah, it is very interesting, but I do think, it's like, I think people, old mindset, you just say, oh, don't Google it, don't search on the internet, you'll never learn. And now, at least at Turing, they're like, you're learning how to search the internet. I'm learning how to use ChatGPT.
Yeah, I've always been a big proponent of like, there's nothing wrong with using Stack Overflow, especially if you know to read all the way to the bottom. Because you can't remember everything.
A lot of times it's the third uploaded solution that fixes my problem.
You can find libraries that already exist that sometimes you don't even know what they're. Okay, now you go study that. Okay, now I know that.
Well, does prompting go with the same problem of Stack Overflow? Like I don't know what to search for here, so how am I supposed to find the answer?
That's
Same
the
thing as
truth.
your prompt. Exactly.
What this young man over here said, your name?
Kyle.
What Kyle said was like it was helping you develop a spidey sense.
Yeah, a little bit.
Like in a different way, but like, everyone develops that sort of like ability to give an eye test. But it's just like, it's influencing how you, how you evaluate that eye test, right? So, but it's like, it's a different like base of knowledge. Like you're not starting from a fundamental base of knowledge. You're starting from a knowledge of interacting with the tool, which is like, that's an interesting sort of like instinct you create. I don't want to say instinct, but like, thank you, intuition that Jason said. So, all right, thank you.
There's like an interesting aspect of like what you're trying to get out of the AI also. Like if it's code, and I think especially Ruby code, like I know it works because I can run it. But if I'm trying to figure out some kind of implementation detail, like Postgres or something, I don't know if it's right. I would have to go and find the right documentation, find the source code. It's like much harder to verify stuff that I can't like test or run immediately.
I mean, also on a very basic level, I've used it to study like data structured algorithms through V code, things like that. And it's really good at explaining like why things work. And that's like, I'll say like, like why can't I chain it like this and why can't I chain it like that? and it'll like go pretty in detail, and I'll use it as like a tutor essentially. And so it's really good at things like that. But I've noticed that in like my personal projects, it like doesn't know how you set up your file structure a lot of the time, right? And so like prompting it with certain information, I don't know. Even that was a learning curve, like knowing what to tell it. So yeah.
So Scott, how close are you all to a product that's releasing, like based on this stuff?
We're close. We're going to be doing some early pilots kind of next month to really kind of push. We've basically just been using it internally. So now it's a little bit of like, let's try it on some real world things rather than toy problems.
And is your project the product in Ruby right now, or is it in some other language?
We're kind of doing it in a bunch of different ways. So we've got the first version was in Ruby. We're exploring like Elixir, exploring this like Ruby method missing piece, and some JavaScript as well. Different attributes of different languages. We're kind of trying to see which ones. Very, very experimental right now. Like, you know, the Erlang actor model seems to have some interesting flows to it.
Do you have a sense of whether it's more accurate with types versus no types?
That's something that we're debating a lot internally. You know, there's some research that's come out that you know, the longer the response is, the more likely it is that it's wrong. And so, and so like there is a little bit of a, you know, a push to have smaller responses. And so in that case, like, you know, maybe types fall out where they're adding additional characters, tokens. And, you know, and whether, you know, the whole debate of like, do these actually understand what they're doing, or are they really just like a really fancy autocomplete? And if it really understands, then types will probably end up being something else. But if it's just fancy autocomplete, that's really just extra characters that you're gonna have to like look at and make sure that like, does this actually make sense, right? And you know, something like Ruby where it's more conceptual or more you know, conversational, where it's more closer to natural language, maybe that ends up lending itself well, but still an open question. But something we're definitely exploring.
Cool.
I have one last question, unless anyone else has something. So what are those old-timey things to your left behind you? It's like a shelf or something? I'm not sure.
Kind of like analog Kindle.
Thank you so much, Scott. It was really a pleasure.